Hi, I'm Paul Marcel. Lately I've been working on a project with a lot of crazy angles on it. This is on top of a cabinet that I'm going to be using as an entertainment center, but each side of it's got about 16 compound angles on it on this side, and then of course on the other side mirrored. And then this is repeated 3 times throughout the cabinet. So now computing these angles out to 16 decimal places, that's a piece of cake. But the problem is, how do I actually get the saw to cut something at these angles so that at the end everything fits all nicely like it is here in this taped up mock-up that I have of the piece, and not have to resort to using a big sheet of sandpaper stuck to my assembly table and sand it like a jewelry box. Now normally in setting angles like that, you'll get one of those little protractor triangles and you use a transfer bevel. You'll kind of eyeball it where you need it to be. But when I'm computing angles like I have on here, I've computed these out to 1,000th of a degree with the intention of trying to get as close as at all possible for doing that. Now, me eyeballing it with this, I'm probably going to be only within 1/10 of a degree at best. Now, if I'm off by 1/10 of a degree, each one of these joints has 2 angles. There's a bevel cut and then there's a miter cut on here, and then the same on the other side. It's different. So if I'm off by up to 1/10 of a degree, all that compounding all the way around, that back piece is not going to be laying flat at all on this bench. So when I conceived of this project a long time ago, that was right at the time that Bridge City Toolworks announced the AngleMaster Pro. So I put this project on hold until this came out so that I'd be able to use it for setting these angles, because this is exactly the answer of what I need. So the AngleMaster Pro is basically a device for measuring or setting angles that works on obtuse angles. So it only works from 180 degrees up to 90 degrees. Now if you end up needing to use an acute angle, that's when you can use something like your transfer bevel. You can just bend this down and then you can mark the angle here for what would be the complementary angle, and then you can go use that to set up your tool. Now the way this device works and sort of the math behind it, I'll cover that a little bit later in this review. And I'll put it after the review because not a lot of people care about cosines. So the way that the tool works, it's got simply some pivot points down here. Now these pivot points, actually, if you've ever opened up any of these, and don't ask me how I know, they have little acetal bearings on the inside of these. So these move very smoothly and very noiselessly just because they're basically acetal plastic bearings. Now there's no play in the device whatsoever, and that's paramount if you're going to try getting some accurate angle transfer. Now when you get the AngleMaster Pro, you actually don't get the caliper. That's something that you provide yourself. Now the caliper is going to be reading basically what looks like the hypotenuse of a triangle that's formed on the inside, but we'll talk about that later. But the key point is that a caliper that you attach on here is going to be reading linear distances. The distance between these 2 points here is what it's reading. That actually doesn't translate directly to an angle. For that, there's a translation function, and those are actually written on the back of the AngleMaster Pro. But we're going to talk about that a little bit more later. The caliper that I purchased is a Mitsutoyo Absolute caliper. It's supposed to have an accuracy of within 0.02 of a millimeter. So to me, that's pretty good. That actually translates to, if you were to do the math throughout the range of linear motion, that's actually going to get you to within 0.02 of a degree. At worst case, you're going to be possibly off by 0.02 of a degree with this setting using the caliper. Now the AngleMaster itself are these black arms here that you see, and then the 2 holders that hold the caliper in place. That's what you would get if you were ordering this. Then you'll attach the caliper using some pretty simple instructions that come with it. The arms here are actually shaped like male dovetail slides. This is so you can add accessories that come with the kit. Now this is one of the knife accessories. It's just a very thin blade, something that you would use if you're trying to set an angle on a table saw, and I'll show you that a little bit later. But you would just slide this over the edge here, and then you can lock it into place. And then this would be used to place it up against the table saw blade so you can get it between the teeth and get it right up against the saw plate. Now some of the other accessory bases, there's one that's just simply flat. The reason why you might be interested in one that's simply flat is both of these arms also include some rare earth magnets on the bottom of them. So that this way here, if you're doing some measurements and setting some things on your table saw deck or on your bandsaw or anything like that, it's going to stick to the deck very well. But of course there's some times when that's actually a little bit annoying. So what you can do is you can put this one here on. It's just a plain flat one. You'll be able to slide that on and lock it into place. And now the magnetism is reduced here to the point where it's not going to be interfering with anything. Now the last base that comes with the kit has a VGroove in it. Now what the VGroove is going to be very useful for is if you want to place this on something that's round, anything like that that has kind of an unusual shape, something you're not going to be able to place it flat on and then have this thing rotate, you're going to be able to place it right into that slot on the groove, and it'll make it a lot easier for you to transfer measurements or take measurements. Now while we're talking about the accessories, there is an optional accessory for the AngleMaster, and that is basically a small spirit level that you can attach to the body itself. So let's say in somewhat of a civil engineering application, you might have a pole in a structure that you're going to be aligning this to. So you might attach this to the side of the pole, or you might end up even using the VGroove to put it against the pole. If you're then trying to find the angle between that and the horizon, because you're not certain that that's actually dead level, well, then you'd be able to use this to be able to figure out what that angle is between the two. Now, of course, for this to be accurate, it has to be calibrated in the first place. When you first put this caliper on there, there's going to be a procedure for attaching it and pre-calibrating it so that it's going to be in the right place. But of course, this thing needs to be able to get to a dead 90 degrees. And the way that that is it comes from the factory pre-calibrated using this piece here that acts as a stop for where the 90 degrees is. And then that's going to end up setting where all of your calibration points are. Now, as I mentioned, the linear measurement that comes off of the caliper does not directly map to an angle, so you need to have a way of doing the mapping. Now, it turns out that Bridge City has an application online on their website that lets you type in a caliper reading, it'll tell you what the angle is. Or if you want to search for a certain angle, you type that angle in, it'll tell you what caliper reading it goes with. And of course, that means you kind of would want to have a computer in your shop, whether it's on your screen there or if you have an iPad or some other device like that you can use it. Now, a more convenient way is that there is an application that's available on iPad. There's one that they actually promote for the Angle Master, although this one here happens to be one that I made for myself just because I like this one a little bit better. It does all the calculations that I needed for this project here, so I like it a lot better, but it's going to be a little bit more convenient in the shop to have something like an iPad. Now, if you don't have an iPad or an iPhone, then what are you going to do? It turns out that the back of this Angle Master has all the integral degrees etched on it, and it gives you what the caliper readings are going to be. So you're going to get everything like 42, 43, 44 degrees, anything like that for tilt angles off of 90, as well as the full obtuse. I mean, they're all the same numbers. They're going to give it to you in two different columns, so you know that this is either 0 tilt or it's 90 degrees obtuse. And then it'll tell you what the caliper reading is going to be for this angle setting. Now, since I hinted before that the math involves a cosine, then you also know that the distance between two different degrees is not necessarily going to be linear with the caliper. So what happens if you actually want something like 42.4 degrees? How accurate is it going to be when you're looking at the back here and you see a 44 and you see a 45? It turns out that if you do a linear interpolation between the two, so like 44.5, okay, well, take the caliper reading for 44, take the caliper reading for 45, and average the two. How far off are you going to be? It turns out that you'll be at most 0.02 of a degree off anywhere throughout this motion. And actually the highest error is only when you get down to about there. So anywhere in here you're going to be within 1,000th of a degree if you just do some simple interpolation like that. So that said, it means that you don't actually need the application in order to use it, and it is kind of convenient that you can just pop out a calculator and do the quick math for doing some of the angles. Now, some of the application programs can make it a little bit easier. And in fact, in the case of my project that I'm doing, I'm using a number of triangles for setting all the compound angles that I need to cut. And what I did on these is I wrote both the calculated angle that I had from the regular math, so just regular degree angle, and then I also wrote down the caliper reading immediately. So this way here, I don't ever have to go back to the tool and start typing in degrees. It's already been done once on here, and then I use this for, in the case of this project when I did the whole thing, all 84 cuts. So this project is actually online if you want to go through it. In fact, if you have an interest in the Angle Master Pro, I'd really suggest that you go back and look for my project called Angle Madness and look at the second episode, which is called The Jigs. It'll go through and explain how I created these by using the Angle Master in order to set the angles, and then afterwards to validate them and actually apply little error corrections here with some simple tape. I think you'll find that there's a lot of good clues of how to use this tool in the real world. And normally what I do is that I'll place this on the table because it's magnetic, it's going to snap down, so this is perfect. What I'll do is I'll make sure that the tilt is greater than the Angle Master, what we're trying to get. So let me crank this down a little bit more. I also like to have the blade up high. I want a lot of registration to the little registration surface that we have here on the Angle Master because it's going to make it clearer when we've got the thing set. So then you scoot this thing over and you touch the plate. Try to make sure that there's no tooth here in the way because you're going to want it to be on the saw plate when it touches and registers with the Angle Master. Now the other thing you're going to want to make sure you do is when you line this up, make sure you're lining it up pretty much, just eyeball it to be perpendicular to the blade. If you have it here, or you have it here, that's a different angle. Just like when you're taking a hand plane and you skew the plane, you're giving it a different attack. As you skew it, you're lowering the angle. When you're skewing this, you're changing the angle so that it's actually going to be less of a tilt. So just eyeball it to 90 degrees, make sure there's no tooth in the way, make it touch the blade. When it touches the blade, because it's magnetic, as I change the bevel on the blade and I move it up to match this tool, it's going to push this over onto the table and it's going to keep a nice snug fit. It makes it super easy. So now you just crank it up. Go until you don't see the light. Just killed it. To me, that's set. So if we were to switch into a little bit of a mathematics mode, if you're kind of curious about, well, how does this mapping go to an angle? The way it works is it works off of the law of cosines. We've got, basically there's a small triangle over here on the side, and then there's a triangle here on the side. Those have fixed angles. It turns out that their angles combine to 45 degrees. So when this is closed, this triangle here on the inside is 45 degrees. Now that part we don't really care about too much. What we really cared about is what the constant part of this triangle is and the constant angle of this one. So that way there, when we calculate the angle of this inner triangle, we know how much to add to it to get to this obtuse angle. So basically we know, when we get the angle of this inside one, we're going to add 45 degrees. And that'll be our obtuse. So the way the law of cosines works is it's if you remember back to trigonometry, there's the Pythagorean theorem, so you have, the a squared plus b squared equals c squared. Well, that's actually a special case of the law of cosines. Law of cosines being the more general version of the equation. So the way that it works is, with this being the hypotenuse, this measurement here squared is going to be equal to this measurement here squared plus this measurement here squared minus 2 times this distance times the cosine of this angle. So yeah, we can solve for that because we already know that these distances, they're fixed and we know the value on both sides here. We know this value because of the caliper. Now, when the caliper is closed and it's zeroed, we actually know how much to add. It's this additional distance here and here on the side. So basically, we know the distance from this point to this point on the angle master, and then we're just going to add whatever number is on the caliper for making our value of C. So with that, you can run through all the math and then you can come up with the angle. So that's actually what the program that I wrote did. It just does that. And that's the same calculation that's being done online with the web and also with the macros that can come with this financial calculator that they also recommend that you use with the Angle Master. So again, I'm going to remind you that I did the calculation where I ran it through all the integral degrees to find out, well, how far off are you if you're trying to interpolate at the degree that's at the half? So like 44.5. If you were to do a linear interpolation, how far are you off from the actual computed value? Turns out you're only going to be off by 1,000th of a degree. And since the accuracy of your caliper being plus or minus 2/100ths of a millimeter results in being off by up to about, at worst it's going to be 2/100ths of a degree, but on average it's 100th of a degree. So since your caliper is actually going to be a far greater error than that interpolation is going to add, don't worry about it too much. Just go ahead and interpolate off the back if you don't have either one of those applications.